Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of Transpower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. I also work as a theoretical economist and operations researcher. My very first commercial software package is called Optimal Manager, came out in 1982. It's a very comprehensive operations research and management science software package, including all of the elementary intermediate level operations research and management science applications using all kinds of mathematics, but the mathematics are included within the program. So unlike a spreadsheet, you don't put in the equations are already in. All you have to do is supply the data for your company. So we've been doing one program unit per week. You can see the sign on screen here, Optimal Manager software package, 47 program units to optimize your business. And but many of the program units contain sub-program units. Today's program unit, which is inventory control, has 4 sub-program units actually. So I hit enter here. We're currently in optimal product manufacturer. We completed all the program units and optimal product investments. So I'm going to hit II. And we're currently on program unit 4, optimal inventory of materials deterministic method. So I hit 4. Would you like to see the program unit description? Yes. So I'll just read this to you. By the way, a manual is available, printed manual is available, but you really don't need it. It's an extra $95. Originally the whole package software and the printed manual sold for $495 for many, many years. Last year we reduced the price all the way down to $95, just because we can give a download link from Dropbox. You can still get the manual separately for $95, but it's not necessary because all the descriptions are included within the software itself. And even though I wrote this in 1982, I'm still very proud of the interface. It's extremely easy to use. And in fact, just one use of this program might be enough to pay for the cost of the package for your business. Okay, so reading the description here for optimal inventory of materials, deterministic method. This program unit solves the problem of how to minimize inventory costs by computing the optimal quantity to order, the optimal time to order, and the optimal amount of back ordering to allow, if applicable. 4 deterministic inventory models are available. 1. Infinite delivery rate with no back ordering. 2. Finite delivery rate with no back ordering. 3. Infinite delivery rate with back ordering. And 4. Finite delivery rate with back ordering. So hit enter. Continuing with the description. Inputs to all 4 models, subprogram units, consists of the annual demand for the product, the ordering cost per order, and the annual inventory holding cost per unit. In addition, models 2 and 4 require the arrival rate of an order in units per day and the user sales rate also in units per day. And models 3 and 4 require the annual back order cost per unit. For each model, the program unit outputs consist of the optimal quantity to order, the average inventory level, the number of orders per year, the annual ordering cost, the annual inventory holding cost, and the total annual inventory cost. In addition, for models 3 and 4, the program unit prints out the optimal quantity to back order and the annual back order cost. Standard management science formulae derived from the calculus are used in this program unit. Hit C to continue. Do you wish to use data from this file? Yes. I'm going to use all the sample files here. So 1, E to edit. And here you just type in the report type. This is infinite delivery rate, no back ordering. Name, company, date. This is handbags in this case. Annual demand is 2,100 units. Ordering costs per order is 25. Average inventory holding cost 10.75 per unit. Accept that. So we're going to choose model 1 here. So if I hit E to edit, it just goes there. So we're going to use 1. Infinite delivery rate with no back ordering. Accept. compute only, screen only and screen length for the output. Everything is nicely aligned here. Annual demand for the material product is 2100. Ordering cost per order is 25. Annual inventory holding cost per unit is 10.75. So the program tells us that the optimal quantity to order is 90.83. You could round that up to 91, for example. Average inventory level 49.42. Number of orders per year 21.25. You could just round that down to 21. Annual ordering cost is 531.21. And same thing for annual inventory holding cost, 531.21. So that's where you know it's optimal, where the average ordering cost is equal to the average inventory holding cost. Total annual inventory cost is the sum, or 1062.43. Okay, so now we'll exit out. We'll come back in. And we'll skip the description this time, and we'll go right to file 2. So this one is finite delivery rate, no back ordering. I'm just going to accept that. This is model 2. I'll hit E to edit. It shows you model selection is 2. Finite delivery rate with no back ordering. Arrival rate and order units per day is 30. And we have 7 units per day for use or sales rate. Accept. Compute only. Screen length. And here we go. So annual demand for the material product is 2100. Ordering cost per order is 25. Annual inventory holding cost per unit is 10.75. So therefore, the annual rate, units per day of the order, is 30. Use or sales rate, units per day of material is 7. So therefore, the program tells us that the optimal quantity to order is 112.87. You can round that up to 113. Average inventory level 43.27. Number of orders per year 10.61. And the annual ordering cost equals annual inventory holding cost 465.13. So the totals just double that, or 930.26. Okay, either exit, come back into optimal product manufacturer, go to 4. Optimal inventory materials, deterministic method. Skip the description. Let's load in file 3. Edit this. This will be infinite delivery rate with back ordering. So that's name, company, date, handbags again. 2100 is annual demand. Ordering cost is 25, and average inventory holding cost is 10.75. Accept. And go edit this. This is model 3 now, which is infinite delivery rate with back ordering. Annual back order cost is 15. So there's a cost for back order for models 3 and 4. Accept. Compute only. Screen only. Screen length. And here's our output. Annual demand for material product is 100. Ordering cost per order 25. Annual inventory holding cost per unit 10.75. Annual back order cost per unit is 15. Optimal quantity to order 129.49. So you could either use 129 or 130. Average inventory level 21.97, or about 22. Number of orders per year 16.22. You could round that down to 16. Optimal number of units back ordered 54.06. And the ordering cost is 405.24. The annual inventory holding cost is 236.10. The annual back order cost is 169.26. So therefore, the total annual inventory cost is 810.88. All right, so we got one more to do here. So I 4. Skip the description. Load from the file. We'll do 4. This will be model 4. So you need to edit. So again, here's finite delivery rate with back ordering. Name, company, date, handbags again. 300 is annual demand. 25 is the ordering cost. And inventory holding cost is 10.75. Accept that. Hit E to edit. We're in model 4. Again, finite delivery rate with back ordering. Arrival rate and order units per day is 30. Use rate or sales rate is 7 units per day. Annual back ordering cost is 15. Accept. Compute only. Screen only. Screen length. And here we go. As usual with all the program units, the input is all included in the output. So annual demand for the material product is 2100. Ordering cost per order 25. Annual inventory holding cost per unit 10.75. Annual back order cost per unit is 15. Arrival rate units per day of orders 30. User sales rate units per day is 7. So the optimal quantity to order is 147.89. You just round that up to 148. Average inventory level 19.24. Number of orders per year 14.20. So you could, just 14 orders per year. Optimal number of units backward 47.33. So now we get the totals. Annual ordering costs 355. Annual inventory holding costs 206.8. Annual back ordering cost is 148, and summing all those, total annual inventory cost $710. Exit to the module menu. Okay, well, that was pretty comprehensive for inventory. Next week we'll do the probabilistic type of ordering system. But you can see, so not only do we have 47 program units, but many of the program units also have sub-program units. So this is a very comprehensive operations research and decision support and management science software program. As I said, the price has been reduced to $95. We just send you a Dropbox link. We provide free phone and email support for anything related to the program for the life of the product, so there's no support charge. And like I said, probably just the 1 or 2 uses of the program, it'll pay for itself. All right, well, that's all I have for you today. I wish to thank you for your attention. Please like my YouTube videos and please subscribe to my channel. It'll be helpful in getting the word out to a lot more people. We need to make operations research and management science available to all the small and intermediate level businesses out there which are not currently using operations research and management science. So this whole package, Optimal Manager, makes it easy to use all the major techniques of operations research and management science. As I said, all the equations are included within the program unit, so you don't have to put in any equations yourself. It's not like a spreadsheet. It's extremely much more advanced. Okay, that's it for today, and bye for now.